Well, 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 a new example had entered the arena. A cliffhanger at the end of our last video about completing the square. And I'm going to show you how to do it right now. And so, solving this quadratic equation when there's an a value. Let me tell you what. Well, completing the square, we're going to want that a value to equal 1. And so no matter what this is, my first move is just divide everybody by it. Everybody. And in this case, it's at least friendly enough that all the fractions simplify here for us. All right, and so now to complete the square, I want to get this over to the other side, right? So I can get a new c term. So I'll have x squared plus 10x. I like to leave this little space of foreshadowing. Ooh, because I know I'm going to have a new c term in a minute, and I'm going to add it to both sides. So let's find that new c term. So c is going to equal the 10 divided by 2, all squared, which notice this b is not the same that the original b was. It ended up being less than that. And so let's see. 10 divided by 2 is 5. 5 squared is 25. And so I'll add 25 to both sides. I can now fast factor this. So I'll have x plus what all squared? Half of that 10. Boom. Equals 29. And now root, both sides, plus or minus, don't forget it. X plus 5 equals plus or minus the square root of 29. And then subtract 5 from both sides. And let's get us some decimal approximations, shall we? And so one of my answers is negative 5 plus the square root of 29. So calculating. 0.39. And the other one is negative 5 minus the square root of 29, which is negative 10.39. Excellent, excellent. And so there are my two answers. The exact answers, by the way, were the, negative 5. X was exactly equal to negative 5 plus or minus the square root of 29. Which, using any, properties of radicals and stuff, we would simplify that if possible. Here, I just realized they just said complete the square, solve by completing the square. This is probably the answer they would have been looking for there. But if they said approximate, then boom, that's what your approximations would have been. All right, let's do another one. So, is there an a term? Divide everybody by a. Everybody. Every single term. So g squared minus 8g plus 9 equals 0. Get rid of this old c term. We want a new one. G squared minus 8g blank equals negative 9 blank. You don't have to write those blanks. I just like to... I'm not looking for a new b term. I'm looking for a new c term. So I'm going to take b divided by 2 and square it. So that's negative 4 all squared equals positive 16. So add 16 to both sides. Fast factor is what I like to call this step. It's going to be g minus 4, right? It's just this thing here. It's half of the b. Yeah. Equals 16 minus 9. What is that? 15? No. 17. What am I thinking? All right. Now to solve for g, my g's are looking like y's. It was going to slowly evolve over time there. Root both sides, plus or minus. Don't forget it. And I get g minus 4 equals. I cannot simplify that radical, but now I can just add 4 to both sides. And so my approximations. G is approximately, whoa, you're clunking my calculator. 4 plus the square root of 17 is 8.12, and 4 minus the square root of 117 is negative 0.12. And so we solved this problem, which never would have been factorable. And we, did great. So, all right, check this out. Turns out you can also use this strategy to find minimums and maximums of graphs quite easily. We're going to use the completing the square method, because the completing the square method is great for finding perfect square trinomials and writing things as square of a binomial, which notice shows up inside the vertex form of a parabola, quadratic function there. And so we're gonna use that and then find the vertex, just pulling from the h and the k, and we'll know that k is the max or min, depending on if the parabola opens up, it'll be a minimum, and if it opens down, it'll be a maximum. All right, and so let's see. Let me show you how to do this. So I'm gonna take this part here, and I'm gonna try to take just this and complete the square. And there's a couple ways I could show it to you. I'm gonna show it to you the Waddy way. So I'm gonna just x squared plus 4x blank. The -1 is hanging out, and then blank over here. And let's find our new c term. So new c, 4 divided by 2, all squared. That's 2 squared equals 4. And so I'm going to add 4 here, but notice I'm on the same side of the equation. So normally I would have had to add 4 over on this side too, but I'm going to just keep all my work over here, and the way I can make it fair is subtract 4, right? So this side was getting some unfair treatment. They were getting added by 4 over here. So simultaneously, let's subtract 4. Makes things square. Haha, completing it even. So let's fast factor this part. So I'll have x plus 2 all squared. -1 and -4 combine to be -5. And I get y equals that. And so notice, using my old strategies, I got a is equal to 1. I've got, you know what? Oh dear. Oh dear. I got to grab my sky blue. And I don't even have my inkwell here. H is equal to -2. K is equal to -5. Remember the weird thing about H's, it's always the opposite of the number that's with the X. And so my vertex is -2, -5. And now because this parabola opens up, right? Opens up because A is positive, you're imagining a parabola like this. The vertex is at the bottom, therefore it's a minimum value. And so the minimum value is the -5. The lowest this parabola ever gets is that y coordinate. All right, let's do another one. Ooh, what if it was a maximum value? All right, so I'm going to want to complete the square here. There's a couple different ways to deal with this. Now, this minus sign, I am going to factor out GCF style a -1 from just the first two terms. Yeah, crazy. So this +7 is still hanging out. All right. I've got, now it's a positive x squared and a -2x. All right. All right. All right. I'm going to try to complete the square of what's on the inside, and I'll have to balance what I do with something on the outside. So let's find a new c term. New c term. So that's going to be -2 divided by 2 all squared, -1 all squared equals 1. And so I'm adding 1 in the world of parentheses. But notice what I'm really doing is subtracting 1. And so if I subtracted 1 on this side of the equation, I would have also had to subtract 1 on this side of the equation. And since I'm just trying to do all my work over here, I'm gonna undo that by just adding 1. Okay. And so yeah, don't be these, by the way, are not necessarily always the same. note this problem here. Here it was plus, here it was minus, but that was because that was positive. And so let's fast factor, shall we? So I've got y equals -1 parentheses x minus 1 all squared plus 8. Where'd this -1 come from? It's half of that. It's the thing that I had before I squared it. And so let's write this down. So a equals -1. Let me get my sky blue here. H equals +1. K equals +8. Remember, this is always the opposite. OPP. So my vertex is 1, 8. Now, this a value being negative means that the graph opens down. And as a result, the vertex is a maximum, right? Because if it opens down, the vertex is on top of the mountain. It's a maximum value. And the max value is the 8. Okay. So that's how we can do these in, rewriting in vertex form sort of stuff. It's quite helpful for rearranging that. If in your pre-calculus class you end up doing stuff called conic sections, you'll rewrite equations of circles and ellipses and hyperbolas, all using this completing the square strategy. And so it becomes quite helpful later on. Let's see. I'll speed run this one right here because of the negative. So because it's got an a value that isn't 1, I'm gonna take that a out. I'll have +x squared. I'll have +4x. I'm gonna find a new c term. This +4 is hanging out on the outside, and so I've got y equals that. Let's find that new c term. So c is equal to 4 divided by 2 all squared, which is 2 squared, which is 4. So I'm going to add 4 in the world of parentheses, which was really subtracting 4. And so to balance it, I'd have to add 4 over here. And so fast factor, I've got y equals -1, x plus 2 all squared plus 8. And remember that 2 came from just dividing the b by 2. Or it's always the thing that I had right before I squared it. Oh dear, I just undoodled that. And so a is -1, h is -2, k is 8. It opens down and has a maximum value of the 8, the k value. Nice, nice, nice. All right, let's do some real life applications. So if you're launching a rocket and you are able to calculate, model the rocket's height with an equation, like so, we can now figure out, using completing the square, that maximum height. That's great. And that might be helpful to know, right? And so here we go. First thing I'm going to do with this equation is I'm going to write it in vertex form. So I'm going to take the -16, whatever that is. And notice I'm not quite doing a full GCF. A full GCF, I would have stolen an x from each of these. I'm just factoring out a, no matter what. Whatever a is, I'm stealing it. So I'd have x squared. I feel like I should know this. 6 is 96 divided by 16 is 6. And so a -16, right, it's going to be a -6x there. So I'm going to complete the square here, and whatever I do here, I'm going to have to do something to the outside there as well. Let's find my new c term. So new c is going to equal the b divided by 2 all squared, which is -3 all squared, which is +9. So in the world of parentheses, I'm adding 9. But in the world of the equation, I'm technically, whatever 9 times -16 is, -144 is what I'm technically, I'm subtracting 144. What? Right? Is technically what occurred when I added 9 in the world of parentheses. And so to balance that, I've got to add 144 here. Okay, that part's a little sneaky tricky, so be careful. So I've got y equals -16 x minus 3 all squared plus 144. And so you can see the a value, it opens down, h is +3, k is 144. The maximum height is 144 feet. The axis of symmetry is going to be the x equals h. Let's see, so the axis of symmetry is an equation, x equals h. It's going to be x equals 3 in this case. And interpret the axis of symmetry. Well, tell you what, if the path of the rocket, right, is doing this, x equals 3 would be this equation, which actually, nope, this doesn't actually represent the path of the rocket. Y was just the height of the rocket, and x was the number of seconds. And so x equals 3 would have been 3 seconds. And so that's actually, it takes the same amount of time to go up as it takes to go down, oddly enough. And so it kind of is, it represents half the trip. In time, right? So 3 seconds to reach the top, right? Something like. All right, I think I've got one last example. This one was trickier because you had to factor out a. And that was a weird one. Okay, let's say you had a door and you're gonna make a little chalkboard and a border and blah blah blah. Okay, you want the chalkboard to cover 6 square feet. So here's 6 square feet, and I'm gonna need to figure out these dimensions right here and right here. So if the width of the border is some unknown x feet that I haven't solved yet, right? X and x. What are the new dimensions of this chalkboard rectangle? Well, here's 3 was the whole way across, and I would have had to subtract an x here and an x here. So 3 minus 2x is one of those dimensions. And here was 7 feet, but I would have had this x here and this x up here. And so if I take away both of those, this would have been 7 minus 2x. All right, are the dimensions of that door. And if I want to, or dimensions of the chalkboard. And if I want to find the area, I could multiply those things. And what do I want that area to be? To equal 6. All right, so that the minus 2x thing is a little awkward. It kind of requires you remembering the segment addition postulate back from the days of geometria. But let's multiply this out. So 3 times 7 is 21. Oh dear. 3 times negative 2x is negative 6x. Then I'd have negative 2x times 7 is negative 14x. And I'd have negative 2x times negative 2x is plus 4x. Squared. Whoa, almost forgot the squared. All right, so let's rearrange this and combine some like terms. So 4x squared minus 20x plus 21 equals 6. So find the value of x. All right, good. So I'm going to complete the square to do this. Now notice this has an a value, and so I'm going to have to factor out a from these two terms with variables. So I'll tell you what, I'll still write that in purple here. I'm also, tell you what, going to simultaneously subtract this 21 from both sides. And so equals 6 minus 21 is negative 15, I believe. Yeah. So let's see. Pulling the 4 out, I've got an x squared. Pulling the 4 out, I've got a, oh dear, minus 5x. This problem just got gross. It's okay. We're gonna survive. We're gonna survive. So let's complete this square. You know what I could do? I could divide both sides by 4 first, but I'll do it later. Find a new c term. So the new c is going to equal a negative 5 divided by 2, all squared. We're going to have a little bit of fractions here, folks. Square top and bottom, positive 25, positive 4. So I'm adding 25 fourths in the world of parentheses. Now, what am I technically adding? Oh, well, if I multiply those 4s cancel out. I'm technically adding 25. And so over here, I'm adding 25. Where's this number come from, by the way? It is A times C, oddly enough, in case you're wondering. Let's fast factor this over here. So I'm going to have 4 times x minus 5 halves, all squared, equals 10. I can now solve. I'm going to divide both sides by this 4 first. X minus 5 halves, all squared, equals, actually, you know what? Ooh, I could have simplified this, but because I know I'm square rooting in a second, I'm going to choose not to. Why am I choosing not to? Because the denominator happens to be a perfect square. You'd have been fine if you wrote that as 5 halves, by the way. Plus or minus that, and I get x minus 5 halves equals plus or minus the square root of 10 over the square root of 4 is 2. And then add 5 halves to both sides. Whew, this problem's a little bit of a beast here. I'm starting to get winded now. So 5 halves plus the square root of 10 divided by 2. Plus or minus, plus or minus. And I suspect if I get a negative answer, it probably won't work. All right. Also, tell you what, because these fractions have the same denominator, you also could imagine it this way. 5 plus or minus the square root of 10 all over 2 equals, all right, 5 plus second square root of 10 is 8.16. I hit enter, okay, and then I divide by 2. And I get one answer is 4.08. Now, if I do 5 minus second square root of 10, hit enter, divide by 2, and I get 0.92 when I round. So, wow, oddly enough, oh, this is an approximation sign, by the way. I get 2 possible answers here. What? I was expecting one of them to turn out negative, but that's not necessarily the case. So find the width of the border to the nearest inch. Oh dear. Dear, dear, dear. Oh, guys, that's so crazy. Guys, this is what it would have been so sad, is like if this was a, on Big Ideas Math and you were doing a homework question, we would have gotten our answer in terms of feet, and many people, look at all of this beautiful work, right? These are in terms of feet. And here's the problem. A 4-foot border. How could I have a 4-foot border on a 3-foot width? Aha. So this answer is impossible. Right? Because I can't have a 4-foot border over a 3-foot width. And now the 0.92 feet I'm going to convert to inches. Oh, man. We're doing like fraction work here. This is crazy. All right, now I'm going to remind you how to do unit conversion. So I want inches and feet. So how many inches are there per foot? There are 12 inches per 1 foot. Notice if I multiply these two things, the feet and the feet cancel out. 0.92 times 12, I get 11.08 0.03 inches. So that's the border. I don't like that decimal point. The spacing ended up weird. Whatever. But that's the border of this door. And wow, recognizing that I couldn't have a 4-foot, which, okay, in case you're wondering, 4.08 multiplied by 12 would have been a 48.96-inch border. But yeah, going back and checking to make sure that your answer makes sense in the terms of the real problem is important. Because, yeah, I would have had dimensions that could not work. All right, well, thanks for watching, Internet friends. Hope you all have a wonderful day. Wonderful day.